All right, so we learned about the range last time, and we learned that the range was kind of a poor measure of dispersion in a data set. So now we're going to learn about two very important ones called the variance and the standard deviation. And they really go hand in hand, and hopefully you'll understand why at the end of this video. So start with deviation. Deviation is how far somebody is from the mean, right? So for example, if the average is 70 and you score 80, then you are 10 above the mean. Right? So we're going to find the deviations for the, this is totally a typo, this is the stats exam scores. And if you recall, it was a sample of stats exam scores. And I accidentally had the wrong numbers there, so if you have old notes, fix those so they say 61 and 77. Beautiful. Now, bear with me because I've already done this because my video did not like me, so let me go back and do it again. So this is stats exams, and I'm just going to copy and paste. It'll be easier. All right, so the first thing we're going to do is find the deviation. Now I'm going to be crafty about this, and I'm going to find it using cell references. So equals that value, 61, minus that mean, 74. And I'm going to press F4, F as in Frank. It's up at the top of your keyboard. Remember, that'll give it dollar signs, so it will fix the reference. And so when I drag it down, it stays C12. See? C12, C12. And for the record, we are never going to find standard deviation again by hand. This is a one-time deal just so we learn about what it is. But we don't want to do this by hand. And while I'm on the subject, I'm going to find the sum of these values. There we go. Oops, they made 0. That's problematic, right? Because we want this to work no matter what. But the whole point of the mean is that the mean is a balance point, which by definition means that half of these scores, well, the deviations will work out so that half are below and half are above, right? Every time. Because that's what a mean is, right? So if you have 13 below, it means you'll compensate it for it somewhere else with a 13 above, even if it's part of this 26, right? It's balanced. Well, that's a problem for us because if it means that the sum of the deviations is always 0, but what we really want, I mean, that's what we want for measuring spread. We want to know how deviated things are and then find an average, add them up and divide. But the problem is that we can never add up because it'll always make 0. Oh, but we can add up. And let me show you how. What we're going to do is we're going to turn it positive. Oops. We're first going to make it have that. So in mathematics, there's two ways to make something positive, and we're going to pick the squaring way. The other one is the absolute value, which is also a very valid thing to do, but we're not going to cover it here. So we're going to square everything to make them positive. So I'm going to take equals that cell, caret 2. It's above your 6, so shift 6 and then 2. Gets you 169. And then I'm going to drag it down. Right? Again, that plus sign, I drag it. And then I'm going to drag this sum right over here. Boom. So I took how far everybody is from the mean. Wasn't working. So then I squared it to make them all positive. And that's great because that gives me a number. Fabulous. So I'm going to go paste that all back. Hey, look, it's like I already did it. All right, so I paste it all in there. And there we go. So make sure you understand what we're doing. We're saying, okay, this guy is so far from that arrow, and this guy is so far from that arrow, and this guy is so far from that arrow. And we take the distances from that mean, from that arrow, and then we square them to turn them positive. Instead of having some negative and some positive, we square them all so they're positive, right? And then we added them all up. Now, the population variance says, okay, you add them all up, and you divide by how many you are, and that's called the population variance. It's got this little guy, sigma squared. Right, that's a sigma. It looks like an O with a tail on it. It's a Greek letter S, lowercase letter s. So if ever you're in Greece and you see that symbol, it's not O, it's S as in snake. All right. Now, where am I getting that number from? I'm doing it in Excel, and you will too. So let me type right here, population variance. Oops, if I could spell. It's equal to that number, 1756, divided by 10. Boom. And I'm going to give it a color. How about blue? And then I want the population standard deviation, which will be equal to 175, which will be equal to the square root, SQRT, of that number, 175.6. Hold on one second. All right, now what in the world am I talking about? What am I doing? Well, let me show you. First, I'm going to make this light blue. All right, back here. So the variance is all well and good, but the problem is that it's squared, right? Which like is no good to us. Like I scored 77% on this exam, but my variance is 175.6 percentages squared. Useless, right? I mean, what kind of unit is percent squared? So we have to undo the squaring that we did. So since we squared everything, in algebra, you learn that the reverse of squaring, the inverse of squaring, is to take the square root. So if you take the square root of sigma squared, you're going to get sigma, little o with a tail, lowercase sound if you're ever in your Greece, right? Sigma, and it's the square root of 175.6, and that's 13.25. Let me double check that. Yep, there it is, 13.25. Should really be a squiggly equals because it's not exact, right? We're rounding a lot here. Squiggly. Cool. And that's called the population standard deviation. Deviation, remember, is how far everybody is from the middle. Standard is just another way to say average, right? That's all standard deviation is. It's how far everybody is from the center. Back to the dots. It's how far these dots are from that arrow on average. Doesn't mean that it can't be higher than that or lower than that. It's just saying the bulk of the dots are within 13.25 of that arrow. Okay, now here's a problem though. The problem is that we assumed a population. We assumed that those 10 scores were the only 10 scores that existed. But that's not the case. This was a sample of data, right? There were more students taking that test. These were just the 10 that we got in our sample. Oh, and there was a typo down here. Make sure you change this word to sample. All right. So what we're going to do is we're going to, instead of dividing by n, we're going to divide by n minus 1. So we go back to Excel, and we type sample variance, and we spell correctly. There we go. And while I'm on the subject, I'm going to type sample standard deviation. There we go. So sample variance, you take the 1756 and you divide it, instead of 10, you divide by 10 minus 1. Now what happens when you do that? Well, it makes it larger. Right? Do you see how the sample value is a little bit bigger than the population value? That makes sense, because if you don't know as much about your data set, shouldn't you allow for a little bit more, I don't know, slop factor, wiggle room, whatever you want to call it? This is called, n minus 1, by the way, is called degrees of freedom. It's going to come back to haunt you in later chapters, right? And I don't want to get into exactly why it works because, well, it's really outside the scope of our course. But suffice it to say that you want to make it a little bit bigger because you're working with a sample, not a population. You don't know as much. So you want to say, hey, I don't know as much. I want to give myself a little more, get out of jail free card, a little bit more wiggle on this data set than I'm allowing for because it's a sample. And the long and the short of it is that subtracting 1 makes it perfect. It's just the right amount of added wiggle to the data set, if you will. But other than that, I don't want to get into it much because it's kind of complicated. But again, n minus 1 is called degrees of freedom. It's going to come back to you later on. But suffice it to say that when you divide by n minus 1, it creates the sample variance. Now, for our data set, for these stats exams, which is the more appropriate number? I mean, should you be looking at the population numbers for this data set or the sample? And the answer is the sample, without a doubt, because there were only 10 scores that were in our sample, but it says right here, this was a sample. So there must have been more people taking those tests than we knew of. All right, awesome. Now we come down here to important notes. All right, we will never, ever, never, never find variance or standard deviation by hand again. We will always use Excel or StatCrunch. Let's go do that, shall we? So let me show you these. I'm going to copy and paste them. All right, these were by hand. I better label them. These are by Excel. All right, so equal to, now there's a couple options here. So if you're in the newest version of Excel, it's var.p. P. If you're old Excel, it's VARP, V-A-R-P. VAR stands for variance, P for population. Okay, I'm in the new Excel, so I'll do var.p, parentheses, and then you just say what your data is, which it was these exam scores. Close my parentheses, enter. And there it is. Look at that. No table, no fuss, no muss. No fun in the sums, none of that junk. All right, what about the standard deviations? Equal STDEV. And again, it's going to depend on what your Excel is. I've got the newest version of Excel, so I can do STDEV.P. If you're on old Excel, it's just STDEVP with no period in it. Either way will work, whatever. And then you just tell it what the data was. The data was, for me, it's F2:F11. Or you can highlight it. See, look, exact same values. Impressive, no? I think it's kind of impressive. So easy, so quick, right? So much less work than doing it by hand. All right, then what about the variance? Population, excuse me, the sample variance. So sample variance, VAR, again, for newish ones it's .S, but for old it's just VAR. That's it, VAR, and it'll know. But new ones you can do .S and then say what your data is. There it is. And then sample standard deviation is STDEV. New version it's just .S. Old version it's just STDEV period. You know, with nothing, excuse me, with no period. How about that? And then say the data. All right. Let me clean up that formatting just a sec. There we go. Awesome. Alrighty then. So, oh, I better show you StatCrunch because StatCrunch is also really darn useful. So let me type in these numbers here. So let me get my stats exams. Copy. And go here and paste. And remember, StatCrunch is available for free, right? And it's available online. You can use it on your iPad, whatever. All right, so you go to, let me go, stat, summary stats, column. This should look familiar. This is how we found mean and median and stuff. Click stats exams. Next. And then you can choose what you want. So if you notice, it already does variance, see variance right there, and STDEV, right, standard deviation. The unadjusted ones, see those? Those are the population values, right? Because you're not adjusting them, right, with the n-1 thing. You're leaving them with the n. Right? That's how it works. And then if you wanted any of these other ones, you could click on them or not click on them. It doesn't really matter. Like, let's say, oh, I don't want the Q1s. Ooh, I'll leave max and min and range in there. We just learned how to do those earlier. I don't want standard error, blah, 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 right? So you could do that. Calculate whatever you want. So if you click on them, they turn off if they're not blue. If they're blue, then they're on, right? Calculate. And there you go. I'm going to copy. And I'm going to go to Excel. I'm going to paste it in. Paste. And there they are. So you can see them right there. There's the variance. 195.11. There's the standard deviation there. If you go over here to unadjusted, see those? Those are the population values, 175.6 and 113.25. Oh, let me color them. There you go. Now you can see the relationship. Right? And you don't need these other ones. By the way, I just wanted you to pick up on, notice that range was in there. Handy, huh? Right? StatCrunch finds range as well as these other values, right? Variance, mean, all that good stuff. There, I picked a different color coding. That way range matches, so that way all the ranges are yellow. But there you go. All right, so now you've learned how to find it with Excel, with StatCrunch, right? And by hand, which you will never do by hand again because you're not crazy, right? Use Excel, use StatCrunch, right? StatCrunch is free, man. Use it. All right. Let's stop here because we've already shown how to do this with formulas. I'll just type up the formulas real quick. Hold on. There we go. We will not be doing this stuff by hand. We will use technology. All right, let's talk about some more technology stuff next time. See you then.